morning, we are from Group A, and the title that we are going to present is The Effects of Operating Conditions on Acid Gas Absorption through Hollow Fiber Membrane Contactor. The acid gases that we are going to focus on is carbon dioxide and hydrogen sulfide, because carbon dioxide is a major greenhouse gas that contributes to global warming, whereas hydrogen sulfide is highly toxic and corrosive, contributing to acid rain. Traditionally, acid gas absorption is by using packed tower, wedge scrubber, and bubble column, but there are some drawbacks occur, especially for operational problems like flooding, channeling, and entraining. Therefore, hollow fiber membrane contactor is used to overcome the shortcomings. Hollow fiber membrane contactor also provides many advantages over the conventional devices. For example, higher interfacial mass transfer area, lower membrane resistance, higher efficiency of gas absorption, and the main difference from the conventional devices is there is no flooding, foaming, and entrapment occur in hollow fiber membrane contactor. Thank you.
The microporous membrane as a liquid gas contacting device using hydrophobic slate Gore-Tex membrane of polytetrafluoroethylene for oxygenation of blood. Hollow fiber membrane contactor for carbon dioxide absorption using a microporous non-wet polypropylene membrane where aqueous sodium hydroxide solution was used as an adsorbent. Besides that, the selective removal of hydrogen sulfide through ultra-low concentration using 2 molar aqueous carbonate solution. There are less hydrogen sulfide absorption was reported because hydrogen sulfide was toxic compound and hard to manipulate. Membrane gas absorption allows mass transfer between two phases without dispersing one phase into the other. The gas fill the hydrophobic membrane pore and meet the liquid at the opposite side of the membrane. Basically, the liquid phase pressure must be more than the gas phase pressure to prevent dispersion of gas bubble into the liquid. The exact absorbent solution pressure must be less than pass-through pressure of the membrane. There are no convective flow through the pore and only diffusion transport of certain components might happen. The combination of absorption, liquid, membrane characteristics, and operation of mode determines the selective removal of the membrane. And then I want to talk on the overall mass transfer process. It can be divided into 3 parts. First of all, there are transfer of gas from the bulk gas phase to the membrane surface. The bulk phase consists of carbon dioxide and hydrogen sulfide. And then the second transfer through the membrane pore, and the last one transfer from the membrane liquid interface into the bulk of the liquid phase.
I will continue to explain the effect of temperature on acid gas absorption. First of all, we must know that there are two types of absorption. The first one is physical absorption and the second one is chemical absorption. Physical absorption is an absorption without including the effect of chemical reactions to the absorption. For chemical absorption, the absorption includes the effect of chemical reactions in the absorption. Okay, in this graph, we can see the effect of temperature on physical absorption and chemical absorption. From here, we can see that when the temperature increases, the rate of physical absorption decreases. While for chemical absorption, when the temperature increases, chemical absorption also increases. The reason why for physical absorption, when the temperature increases, the absorption rate decreases is because when the temperature increases for this absorption, it will decrease the CO2 solubility. It will also increase the CO2 back pressure. These two factors will decrease the rate of CO2 absorption. And the third reason is because it will cause capillary condensation, where CO2 will turn into vapor and fill membrane pores. For chemical absorption, when the temperature increases, the absorption rate also increases. This is because for chemical absorption, there are chemical reactions between absorbent and the acid gases. Even though there are also effect of CO2 bed pressure, CO2 solubility and capillary condensation for this absorption, the chemical reaction will dominate the other effects. In conclusion, we can say that temperature effect basically very dependent on what type of absorbent used. Thank you.
Good morning to everyone. Today I would like to talk about the effect of flow rate of absorbent towards the absorption of acid gas in hollow fiber membrane contactor. In this first slide, I would like to explain about carbon dioxide removal. So in the first case, natrium hydroxide and water are used as absorbents. NaOH experiment represents chemical absorption, water experiment represents physical absorption. According to figure 1, the CO2 flux tends to increase with the increase of both absorbents. In physical absorption, mass transfer tends to take place in between the film around gas and liquid interface. This condition favors to increase of reduction of boundary layer thickness causing by high velocity and high mass transfer coefficient. In chemical absorption, OH ion depletion is reduced by increasing the flow rate of the absorbent and favors to the usage of NaOH. Chemical absorption shows the significant absorbance due to the reaction between CO2 and NaOH. In the second case, 3 types of absorbent are used: Pg, MEA, and DEA. The result shows that the mass transfer of CO2 increased with the flow rate of absorbents, particularly the Pg solution appeared to be the best among them. For the hydrogen sulfide removal, both gas velocity and absorbent velocity, when the gas velocity increases, the reduction occurs in the percentage of acid gas removal. It happens due to the reduction of residence time in the module, which in turn to reduce the removal rate.
Pressure is one of the operating parameters which affects the removal of carbon dioxide and hydrogen sulfide. In this study, they use physical absorption and chemical absorption, where distilled water is used in physical absorption and sodium hydroxide is for chemical absorption. From this graph, it shows significant figures for the physical absorption, while for the chemical absorption it didn't show the result much. While the second graph shows the bubble formation in liquid phase, which the bubble formation is influenced in the absorption of the carbon dioxide. From these two graphs, you can know that in physical absorption, the higher the pressure of the gas is, the higher the absorption. But in chemical absorption case, the pressure didn't show the effect on the chemical absorption. Hydrogen sulfide removal. In this study, they use water as power. They use 3 different flow rates to study the effects of the pressure. From this question, you can see that the higher the pressure, the higher the percentage of hydrogen sulfide removal. While in the second study, they use sodium hydroxide as a chemical absorbent. From this graph also, the chemical absorption increases as the feed gas pressure increases. So we can conclude that for the hydrogen sulfide removal, for both chemical absorption and physical absorption, pressure did affect the absorption.